All right, for 7-4 notes, today's the 16th. Might as well drop your name and date on this just so you have a reference back when we did it, 5/16/16. So the first three definitions in here, we've got a rhombus. And a rhombus is a parallelogram with 4 congruent sides. A parallelogram with 4 congruent sides. Oh, these definitions are right down at the bottom. A parallelogram with 4 right angles. They're right below us in the core concepts. I always find writing stuff helps me remember, so we might as well just be copying here. We're handwriting it. A rectangle is a parallelogram with 4 right angles. So one of the things that I think is important for us to remember is just like that a parallelogram, we keep using parallelogram in our definition, and the definition of parallelogram was a quadrilateral with both pairs of opposite sides parallel. I'm going to drop that up here on the top. A parallelogram, just because we keep using it in these definitions, a parallelogram is a quadrilateral, a quad with both pairs of opposite sides parallel to each other. A quadrilateral with both pairs of opposite sides parallel to each other. I should have done this first. That's all right. A quadrilateral with both pairs of opposite sides parallel to each other. So I was dropping in the definition of parallelogram because I found that every definition that we're writing for the 7-4 vocabulary starts out by saying that the figure is a parallelogram. So let's remind ourselves that a quadrilateral has the parallelogram has a definition of quadrilateral with both pairs of opposite sides parallel to each other. Drop that parallelogram definition on your notes. I'm seeing many of you ignoring the parallelogram definition right now. And again, since we keep referencing it in our new definitions, let's make sure that we're on top of what that part actually is. Yep. Now, last but not least, a square, a parallelogram with 4 congruent sides and 4 right angles. A parallelogram with 4 congruent sides and 4 right angles. So the square is the most specific. Parallelogram with 4 congruent sides and 4 right angles. There's a couple of corollaries, and these are like corollaries are rules that follow definitions. A quadrilateral is a rhombus if and only if it has 4 congruent sides. A quadrilateral is a rhombus if and only if it has 4 congruent sides. And I want you guys to make one notation right here. A square is considered a very specific rhombus. A square is considered a rhombus because it fits the definition. A square is considered to be a rhombus. Because if I go back up here, a rhombus is a parallelogram with 4 congruent sides. It doesn't say anything about angles, and that's true for squares. A square is considered to be a rhombus. And then the rectangle corollary lends itself to us saying a quadrilateral is a rectangle if and only if it has 4 right angles. A square is also considered to be a very specific rectangle. A square is considered to be a rectangle. So this is going to get kind of goofy with us saying, okay, a square fits the definition of a rectangle, so we can call a square a rectangle. When you're ready to go on, turn the page, please. When you're ready to go on, turn your page, please.
So everything is a parallelogram.
As long, not everything, because a parallelogram, both pairs of opposite sides parallel to each other. I can think of one quadrilateral that's not. It's like, I can think of one quadrilateral that's not. Trapezoid?
I can't even picture it.
Can't even picture a trapezoid. Like this.
Oh, yeah.
Alright, moving on. Now, look at where this piece is together. Our corollary 7-4. This piece is together. The definitions of rhombus and rectangle. And that's why we can call a square a rhombus and a rectangle. It pieces together the definitions of a rhombus and rectangle. Just like I told you on the other page, a square is a rhombus and a square is also a rectangle. This says that a quadrilateral is a square if and only if it's both of those things. Of course. Now, specific to rhombuses, diagonals in a rhombus meet at 90 degrees. Diags in a rhombus meet at 90 degrees. Now, last week when we were messing around with this, some of you guys were kind of stuck on, well, what exactly is a diagonal? It goes across our figure from one vertex to the opposite side. I'm in the middle of teaching. Huh? Not right now.
Can you close them?
Rhombus, opposite angles. So this is going to be something that we come back to check to see if a figure is a rhombus. If we have to justify it or prove that a figure is a rhombus. And then the other thing that we see here is in the rhombus opposite angles theorem, that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So diags must be the bisectors of angles. Gentlemen? Diagonals must be the bisector of the angles. Now, in a rectangle, those two are about rhombuses. This last one's about rectangles. In a rectangle, diagonals are the same measure. In a rectangle, your diagonals will be the same measure. You know, and I think about how, where would we be like using some of these rules and this idea about being same measure and coming in at 90 degrees and whatnot. I want to remind you guys of a couple things. Especially back here with this rhombus diags theorem, I want to remind you that if we're in the coordinate plane, perpendicular lines have opposite slopes in the coordinate plane. Perpendicular lines have, I'm sorry, not opposite slopes, slopes that are opposite reciprocals. And that's going to be significant when we have to show or justify that a figure is a rhombus. We'd have to go and count rise over run to get its slopes. This is just something that I know you'll be drawing some figures in the coordinate plane. And then if you're going to justify same measure in the coordinate plane, you may have to use the distance formula or our XY chart of differences to find lengths. So that whole idea of slope and distance is coming back at us again. We have to go back and justify perpendicular lines or even same lengths.